Into the depths of Mordor. Okay, we're all here. Questions on the homework?
I have one.
Sure.
Number 16.
Number 16. All right, let's see if I can draw this thing. This is complicated. So it looks like it's a trapezoid. We don't know for sure, but it certainly looks like a trapezoid. We're just not given that we know for sure that something is parallel. Okay, so let's see. We got something that looks like this, and then this, and we're told that this is 90, and this is 90. Further, we're told that we got that, and then we got some numbers here, and these are side measurements. So this side's 98, and this side is 97, and I'll put this in blue. And then we're told to find, or that these are labeled 1, 2, and 3. And we're asked to put 1, 2, and 3 in order from least to greatest, or from greatest to least, Okay, let's see if we can figure this out. Well, we know if this triangle right here is isosceles, right? So therefore, this angle and that angle are going to be the same. That angle and that angle are the same. Or maybe that side and that side are the same. Let's see. Notice that both triangles share this side right here. So if this is isosceles, oh, we can do better. Instead of doing that, well, I'm going to erase 1 because I know it's isosceles. So that means it's 45 degrees. So 45 degrees, 45 degrees. Why is that going to help me? So now I have an angle measurement. And I guess what the key here is this, is that we know that angle 2, or better yet, since these both...
Yeah, now we know angle 2 is 45.
Well,
angle 2 can't be 45.
It could be. If this side right here was parallel to this side, absolutely. But we don't know that. But what we can say is this: since both triangles share the side of 98 and both triangles share 90-degree angles, then we know that the side opposite of 90 degrees is the longest side. Well, on this triangle, the side that's opposite 90 degrees is 98. But on this triangle, which shares 98, the side that's opposite is that side. So therefore, I know that this side right here, right, from here to here, that's got to be the longest side of any of those triangles. Well, that's not opposite 1, 2, or 3, but at least it gives me a chance of figuring this out because I'm told that this side is 97. So if this side is 98, and this side is 97, then I know that this angle, angle 2, is the second biggest one. And or do I know that? Let me look at this a second. 45, 45. No, I can't say that. But what I could say, do we have external angles here? Maybe we have that. Well, I could say that 2 has got to be less than 45. Why do I know it's got to be? Yeah, that's the way I want to do this. All right, let me get my mouse up here and let me show you. All right, this is what I'm going to do. We know that since this is a 90-degree angle, there's only 90 degrees left. We know that this side is 98 and this side is 97. So therefore, we know that this angle, angle 3, has to be, they're not the same. 98 and 97 are not the same. So we know that the measure of angle 3, has to be bigger than 45 degrees. I don't know what it is, but I know it's bigger. I know that I left off 3, sorry. And we know that the measure of angle 2 It's got to be less than 45 degrees. Now, where am I getting that from? I'm getting that from the fact that, well, they're not isosceles, and that this side is 98, this side's 97. There's only 90 degrees left. It's a right triangle. Therefore, the side opposite the longest side, or the angle opposite the longest side, has to be the bigger of the two. Since there's only 9 degrees left.
So then 3 has to be bigger than 2.
And then 3 has to be bigger than 2. Correct. All right. And then from there, I can get to my answer. So if I know that 3 is bigger than 2, so I'll put 3 over here, and I'll put 2 over here. And I know it's something like that. The question is, where does angle 1 go? On this side of it, in the middle, or on that side of it? And let's
go in the middle.
I think it should have to go in the middle. Why, Ben?
Because if angle 2 is less than 45 degrees, so the measure of angle 2 is less than 45 degrees, and angle 1 equals exactly 41 degrees, then it would go in the middle.
That's it right there. All right, so it should go 3, 1, 2 from greatest to least. 3, 1, 2. Okay, that was a hard one. Anybody else? All right. Here are the answers. Let's see. 1, it's got to be bigger than 3, less than 15. Number 2, bigger than 2, less than 28. Number 3, bigger than 0, less than 200. Number 4, bigger than 3n, less than 17n. Number 5, bigger than a minus b, bigger than a plus b. Number 6, bigger than 5, and smaller than 2k plus 5. Number 7, angle 2 is the biggest one. Number 8, angle 1 is the biggest one. Number 9, angle 3 is the largest one. Number 10, DF is the largest side. Number 11, WT is the largest side. I like number 12. I thought 12 was hard. Number 12, OA was the largest side. Number 13, WY is the largest side. Number 14, Victor Bravo, VB is the largest side. 15 should go greatest to least, C, D, E, B, A. We just did 16, it should go 3, 1, 2. And the last one, 17, should go 2, X, X, Z, Y, Y, and 1. And obviously I left off the measure of angle and all of those. And that was it. Questions? Okay. All right, we're going to do our last one today. Today's our pretty quick class. There's just 2 basic theorems, and they're pretty easy. Maybe about a 30-minute class. We'll do a chapter review tomorrow and take the test on Wednesday. Here's your homework. Okay, 2 quick theorems today, and it's pretty easy. I'm not going to do this demonstration. It actually is pretty good demonstration, but I have to do it in person, so I'm not going to do that one. We're just going to jump right into a proof. All right, here's the basic setup. I've got 2 triangles. You can't judge anything from their pictures, but what you can do is from the marking. So I got 2 triangles, and on the 2 triangles, I have 2 sides of one triangle congruent to 2 sides of another triangle. Further, we're told that the measure of angle B on the seemingly larger triangle is bigger than the measure of angle E on the smaller triangle. We're asked to prove that on the bigger triangle that AC is bigger than DF. Now, it sounds like it should be true, so that's what we got to prove. All right, so we are going to, once again, because you haven't seen this enough, we're going to do an auxiliary line. So here's what we're going to do. I'm going to draw a line from B. Now, remember, angle B we're given is larger than angle E. So if angle B is larger, than angle E, then there must be somewhere where I can draw this angle congruent to this angle, right? Because angle B we're given is larger than angle E. So somewhere here is that perfect angle where now that this angle would be congruent to angle E. So that's what I'm going to do, right? I'm going to make, well, I didn't draw it perfect, but it was close. I'm going to put a ray from B outward so that this angle here, ZBC, is congruent to angle E, okay? All right, I can just do that for basic construction. All right, so let's see. There also exists some point, if I were to measure ED, I know how long it is, but I could do that with a compass, and I were to place that measurement on BZ, I would get another point, we'll call it X, and that point would be exactly, BX would be exactly equal to ED. So that's the next thing I'm going to do, okay? I'm going to find somewhere on BZ that is exactly the distance it is from E to D. So anybody want to take a guess at where X is?
On the intersection between BZ and AC?
Are you guaranteed that?
No, it's just a guess.
Just a guess. It's a good guess. Well, if we think about the possibilities, well, there's three possibilities. Either X is on AC or it's not. And if it's not, it's either on the inside or on the outside. So this is your standard proof by cases. So there's three cases we have to consider. One, that X is on AC, and the other one is X is not on AC. And it sounds like there'd be three cases, X in the middle or X not on the middle. Turns out that there's just two cases. Either X is on AC or it's not. Okay, so case number one, let's assume that X is on AC. So let's see what happens here. If X is on AC, and remember, we drew...
If X is on AC, then the two triangles are congruent, DEF and XBC.
Okay, so if that's the case, you know, by SAS, you can see that SAS. If that's the case, then therefore XC is congruent to DF, and that just further would further emphasize the fact that since AC is smaller than AC, and therefore AC's got to be bigger than DF. So once again, the logic there is that these two triangles, because of our construction, if X is on AC, these two would be congruent. Therefore, since BX is equal to, or BX is equal to ED, then you'd have SAS. Therefore, XC is congruent to DF. And since XC is smaller than AC, then AC's got to be bigger than DF. Okay, cool. That's pretty easy, right? And that's just the segment addition postulate. All right. Case number two, right, where X is not on, I will say is a very, 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 very long proof. And remember I said there's only a few things that I would not prove to you, not because I can't prove this one, but because it's a very long proof. It's on the bottom of page 228. They left off a lot of words, but if you are interested in case two, the case where X is not on AC, well, it's kind of there and it's drawn for you, okay? So you guys can read that on yourself. So just read the other case, case two. I'm not gonna prove that. It's not because it's very hard, it's just because it takes up a lot of space. All right, so let's see, what do we just prove? We proved that if you have two sides and the included, two sides, and you can say something about the included angle. And notice, what could we say that one was bigger than the other? So if you can say two sides of one triangle are congruent to two sides of another triangle, and you can tell me something about the included angle, right? Angle B is bigger or smaller than angle E, then you can say something about the third sides. Now, since this would include two sides in the included angle, this is called SAS, but not congruency. This is called the SAS Inequality Theorem. So the SAS Inequality Theorem has a lot of words here. Book of Truth, please. It just basically says what we just proved. And it says that if you have two congruent sides of one triangle, congruent to two two sides of another triangle, and you can say something about the included angle. You got to be able to say something about the included angle. For instance, angle B is bigger than angle E, then you can say something about the third side. So therefore, you can say that on the third sides of the triangle, the side that is opposite the larger of the two angles is larger than the side that's opposite the smaller of the two angles. Now, just be careful. Remember, we never said what those angles are equal to. We just had an inequality there, that angle B was bigger than angle E. But the so what, I mean, this takes a lot to write it down, but the so what's pretty simple. Two sides are congruent to two sides of another triangle. You can say something about the angles. And whichever angle is bigger has the bigger third side. Doesn't say anything about that third side compared to any of the other two sides. Notice, I don't know how big AB is. I don't know how big BC is. Only thing you're able to say here is that AC is bigger than DF. You can't say that AC is the largest side. It looks like it here. But you can't say it's the largest side because I don't know the distances of the other two sides. If you knew the distances of the other two sides, you might be able to say something. Or if you knew all three angles, you could say something. Of course, if you knew all three angles, we wouldn't need this theorem. We'd use the one from the previous sections. So it's a lot to write, but it doesn't really say much. And I don't think that you're going to be very impressed with the homework because it's pretty simple. Is everybody good?
So judging by this, we're probably just going to do the same thing with congruent triangles, just incongruent triangles, whatever.
Well, they're just going to give you two triangles, give you some measurements, and just say what's the biggest side. That's kind of it.
Okay.
What would be the converse of this?
If you have a bigger side and you know something about the two angle and the two sides are congruent, then the one angle is bigger than the other?
Yes, except it's not that you can say something about the two angles. You can be able to say something about the third sides. So that'll be the next one we do. All right. So the next one is, it looks exactly the same setup. This time, instead of saying something about angle B and angle E, it's going to tell us something about the third side. It's telling us that AC is bigger than DF. And since this chapter also included our proof by contradiction and the contrapositive, that sort of thing, we're going to do a proof by contradiction for this one. Remember, proof by contradictions work well when there's usually a binary or sometimes only three choices. So we're going to prove this one by proof by contradiction. So just so you remember, oh, by the way, there will be a proof by contradiction on the test. So remember, when you do a proof by contradiction, your first statement is still your given. Your second statement will always be that you contradict the proved part. So what statement am I about to make?
That angle B is not bigger than angle E.
There you go. So by contradiction, we will assume the opposite of this. We will assume that angle B is not bigger than angle E, and this is called proof by contradiction. So remember, we're going to make this assumption. It's going to lead us to some, I don't know, some false statement, and therefore we are going to conclude, well, then it has to be equal. Or so it has to be, greater than. This one's a little bit slightly more complicated because this isn't a binary choice. If you're not greater than, what must you be?
Less than or greater than equal to?
Yeah, less than or equal to. So I got to prove, or I got to arrive at two contradictions, one where it's equal and one where it's less than. So this is a proof by contradiction and cases. Okay, so case number one, what happens if it's not greater than, then it must be either equal or less than. So let's assume that it's equal to, and let's see if we can, that's case number one. Let's see if we can arrive at a contradiction. So if angle B is equal to angle E, guess what you immediately have? If angle B is equal to this, guess what you immediately have?
SAS.
Yeah, therefore AC is exactly the same as DF by CP CTC, and clearly that contradicts the given. And the given says that they're not equal. So this is a lot of words right here. So if measure of angle B is equal to the measure of angle E, then those two triangles are congruent because of SAS. And that's not true because we're told from the given that AC is bigger than DF. So that didn't work out. What allowed me to get to that contradiction, the fact that CPC allows me, or CPCTC and SAS, either one, it's fine. Tells
So
me
then we get, if it's smaller, then we get that DF is bigger than AC.
Whoa. Give everybody a chance. So case number 1 can't be true. If we can prove that case number 2, that B is smaller than that, then we'll be there. So Jack's already seen how this ends. Let's see if we can get the rest of you to see how this ends. All right, so if angle B is smaller than angle E, if B is smaller than E, what was the very last theorem we just did? The one that you just wrote down?
Theorem 6.5.
What does it say?
It says that if two sides of one triangle are congruent to two sides of another triangle,
and
technically it says but.
Okay.
But the included angle of one triangle is greater than or less than the.
Either one is fine. Greater.
Yeah, either one. Then you know that the third angle of the first triangle is larger or smaller than, depending on
third side.
Their side, yeah, it is greater than or less than, depending on if the included angle is greater than or less than to the other third side of the other triangle.
So if we consider case number 2, then we're told that measure of angle E is bigger than B. So if E is bigger than B, then therefore then DF has got to be bigger than AC by theorem, whatever it is, that number that we just did, right? But that once again contradicts our given. But we're already told that AC is greater than. So once again, by the SAS Inequality theorem, that's what the contradiction there is. We just contradicted theorem 6.5, right? Therefore, that can't happen. Therefore, there's the only thing that's left. If it's not equal to, if it's not less than, the only other case is it's got to be greater than. So there's a proof by contradiction. Proof by contradiction. Okay. Well, that was pretty cool. QED. Let me clear up all that mess. And this is the 6.6, the SSS. Now remember, we were told that two sides of one triangle are congruent to two sides, and we're saying something about the third side. That's why it's called SSS. So it's not that we know specifically how long that third side is. We just know a relationship with an inequality. If that's the case, right, then you know that the side opposite the third side that's larger of the two, the angle opposite the third side, that's opposite the larger of the two sides, has got to be the largest angle, or I should say larger than the other one that you're comparing it to. That's a lot of words, right? But if you have these two sides congruent to these two sides, and you can tell me which of the third sides is greater than the angle opposite that greater side is bigger than the angle opposite the smaller of the two sides. There we go. So this one's called the SSS inequality. Two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is larger than the third side of the second. Then the included angle of the first triangle is larger than the included angle of the second. That's a lot of words. Everybody good?
Yes.
All right. How am I going to use this? Well, here's your first example. So, Allie, which one's bigger, 1 or 2? And why? I should say, which one's bigger, SV or TV, not angle 1 or angle 2? Which one's bigger, SV or VT?
SV,
Why?
because of Theorem 6.5, SAS Inequality.
Right? And it says that if you have two sides, well, wait a minute, where are the two sides? Well, we're told that that side is congruent to this one. We got a reflexive property right here. And we're told that angle 1 is the bigger of the two. So whatever side is opposite angle 1 will be the larger, not of all three sides, clearly not here, but of these, this side and this side. Of those two, an SV is larger, the larger of the two. All right, and that's using 6.5. All right, Anna, what do you think on this one? Now, this one's in 3D, so it's like a, I don't know, airplane sitting on top of a desk, paper airplane. What can you tell me about angle, what can you tell me about angle FED? Well, actually, I'll just, whoops. My thing is always clicking on itself now. What can you tell me? And I'll label these to make it a little easier. Angle 1 and angle 2, which one's bigger?
Angle 1,
Why?
because of SAS.
And this one's not because of SAS.
Oh,
Notice,
SSS.
yeah, because this one we're told two of the sides and the third side is a reflexive property. Okay. And then once again, because the side that's opposite the longer of the two, we're told that DF is the largest of these two, DF and FG. Oh, this is starting to tick me off now. DF and FG, therefore, the side opposite DF, which is angle 1, is the larger of the two. All right, cool. All right, we'll just do a couple more just to make sure we got this down. McKinley, number 1. Now, I don't care what, you don't need to tell me the theorem. You just need to tell me which angle is the larger angle.
A?
Angle A. Jack, number 2. Which side is larger?
NO.
Yeah. Ben, number 3. Which side is the larger side?
Side TR.
Yeah, and I'm just going to stress this one last time. We can't say that TR is the biggest of all 6 sides, right? But we can say of the 2 triangles, comparing TR to TS, the TR is the bigger, right? All right, Anna, number 4. Which side is the biggest?
F,
F, whatever that letter is. Yeah.
whatever the other one is.
All right, who are we back on? Allie, number 5. What can you tell me?
That UG and is bigger than OG.
There you go. McKinley, number 6. What can you tell me?
TC is bigger than TA?
No, can't say that. It might be true. We just don't know. Notice if this side is N and this side is N, that means they're both the same. We had S with an A in between. So we can say.
Oh, then BC would be bigger, right?
There you go.
Than AB.
There you go. All right. Jack, number 7.
On 7.
Geez, what do they even want there? Did this come out complete? The 1 didn't come out completely here. There's a missing 1. So there should be a 1 right here. So
Okay. So then we have, because of SSS, we have that 1 is greater than 2.
Where are you getting that from?
Reflexive property.
Agreed. It is SSS, but where are you getting that 1 is bigger than 2?
Because 1 has the bigger side.
How do you know that?
Because 6 is bigger than 5.
Okay, that's what I was waiting for. All right, cool. Ben, last one.
Okay. Okay, so I know from this that angle FGE
Must
is what?
must be.
Must be
This is a hard one.
it is, one sec. Wouldn't it be bigger?
It has to be bigger. They're asking.
Yeah.
They're actually asking you to say something about these sides.
Oh, really?
But
Okay.
but in order to do that, yeah, you got to be able to say something about these two angles right here. Oh,
Yeah,
by
so-
the way, if it was a guess, now you got to explain yourself. Why is this angle right here, FGE, bigger?
Because it's the smaller angle.
You got to explain it just a little bit more. I think you're on track.
Yeah.
Small.
Angle FEG is less than angle DEG.
Yeah.
So therefore,
That's exactly. So therefore, since it's smaller than 90, then you're left with, well, you got to make up a whole bunch because remember, it's got to equal 180. This one's already 92. Therefore, these.
yeah, and since lines FG and DG both equal the same thing, that means angles EFG and angles EDG must equal the same thing.
Say that one more time.
Then they shouldn't they equal the same thing?
Because of the isosceles triangle theorem.
Yeah. So
Well,
then if
exactly.
so if there's that means that that's FGE is bigger than measure of angle FGE is bigger than the measure of angle DGE.
Right.
Knowing
therefore,
this information, we can determine that line FE is bigger than line ED.
Perfect. Good job.
Yay.
All right. That's it for today, ladies and gentlemen. 1 through 11, looking at the homework, you might just remember 9 and 10, and just 9 and 10 are colored. Therefore, they are in 3 dimensions. So it's pretty clear on 9. 10 is not necessarily clear that it's in 3 dimensions, but 10 is in 3 dimensions. All right. Any questions on anything we did today? That was only 33 minutes of a class. We have 15 minutes class. All right, so we'll do a review tomorrow. Generally, what I'll just do is I'll have the practice test up. I'll just probably cut the class short tomorrow and just say get started on it. I will be at my computer the entire class period tomorrow, and if you need any individual help, we can do a quick Zoom to explain something. But normal, I'll give you a practice test with the answers. Make sense?
Yes.
Cool.
Yes.
Yep.
All right. You guys have a wonderful day, and I will catch you tomorrow.
Bye.
You
Have
too.
a nice day.